a question from an AP calculus exam. So this is a typical problem that you might run into. It says that beginning of 2010, landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. Okay, so the amount of waste increases by this differential equation, 1 over 25 W minus 300 for the next 20 years. So W is measured in ton, T is in years. Okay, so at T equals 0, use a tangent line at T equals 0 to approximate the amount of solid waste the landfill contains at the end of the first 3 months. So first of all, we need to find the tangent line approximation. We need the X and Y coordinates. So at T equals 0, the waste is equal to 1,400 tons is what they tell us at the beginning here. We also need to know the slope. Well, we need the derivative when at that point. Okay, so we need the derivative at T equals 0, W equals 1,400. Well, we can use that equation. Okay, so I'm just going to do it down here. So we know that the slope that we're going to use for the tangent line is when W is equal to 1,400. So when T is 0, W is 1,400. We only need the W for this. So it's going to be 1,400 minus 300 divided by 25. Okay, so the slope works out to be 1,100 over 25. I think the slope is 24, if I'm not mistaken. Oh, sorry, 44. 25 into 1,000 is 40. 25 into 100, yeah, so 44. So our slope is 44. So the equation of the tangent line then works out to be this. 44 x minus 0 plus 1,400. Okay, so when the W of 1 over 4 time equals 1 over 4 is approximately equal to Y at when X is 1 over 4. So when I plug that in, I'm going to end up with 44 divided by 4 plus 1,400. So I get 1,411 pounds or tons of waste. Okay, so that's how much waste I'd have at the end of the first 3 months. Okay, so part B, I'm going to do part B over here. Okay, part B is the second derivative. So we need to, it says, well, first of all, find the second derivative. Okay, and then we're going to use that second derivative to determine whether we have an the linear approximation is an under or overestimate. So first things first, find the derivative. So the second derivative is going to be equal to 1 over 25. Okay, so that's going to be the second derivative, which means then that it's always positive, which is concave up. Well, if it's always concave up, then our linear approximation, so this line here, is going to be a tangent line approximation, which is always below. Okay, so this is always going to be an underestimate. So this guess here, the one I got, that's on that line. So the estimate is an underestimate. Okay, so that's part B. Part C, okay, let's do part C. It says find the solution to this differential equation where we have a coordinate at 0, 1,400. So part C, we're just going to separate out those variables. W minus 300. Okay, so we're going to separate out those variables. dW over W minus 300 is equal to 1 over 25 dt. Integrate, separate and integrate, we end up with log W minus 300 is equal to 1 over 25x plus c. We can solve for the c by plugging in 1,400. So notice that there's times where I've waited to solve for c. I can sometimes solve for C right away, depending on sometimes equation. Sometimes easier just to plug it in and find for C early. Sometimes it's easier to find it later. Neither is right or wrong. Okay, so x is 0, y is 1400. When I solve for C, I get log of 1100. Okay, and that's going to be equal to C. Okay, so when I solve for C here, I'm just looking at this equation. I probably should have waited to solve for C, but that's okay. So I'm going to end up with log W minus 300 is equal to 1 over 25. I'm just going to write it as x over 25 plus 1100. Okay, log 1100. Log 1100. Okay, solving for W, put it into the exponential expression, e x over 25 plus log of 1100. Well, e to the log 1100 is just 1100. So we end up with W equals 1100 e to the x over 25 and then plus 300. Okay, so there is a solution to my differential equation. Okay. In case you might have missed this step and not really seen what I did here, this was e to log 1100 times e to the x over 25. That becomes 1100. Okay, so that's how I get that 1100 there.